Hey, welcome to my video on 11-4 conditional probability. The aim of today's lesson is to find the conditional probability using tables. So I'm going to ask that you pause your video and answer the 5 following questions based off the Venn diagram that you see. When you are done, you can unpause and we can answer them together. So, how many students are taking a foreign language? Remember, this yellow circle represents all the students taking a foreign language. So if we want to find the total, we have to add up the individual values to get the total number of students taking foreign language. Same thing with sports. How many students play a sport? Blue circle represents the sport. So we have to add up all the numbers within that blue circle to get 24 total students. How many students do both? So if we take a look, this overlapping section, hopefully we know, is the area that represents students who do both. So there are 14 students there. So now they ask a question, how many students do not play a sport and do not take a foreign language? Now, if yellow represents taking a foreign language and blue represents playing a sport, there's really no place left within the circles to represent students who don't do either. So if you take a look in this lonely corner, you'll see these 3 students who don't do either. Since there's no room for them within the circles, we kind of just put them off to the side. Now, hopefully that notation kind of bothers you, and what we'll talk about today will be a way to incorporate that into one of our representations. Number 5, how many students play a sport but do not take foreign language? So we're looking at things that are in the blue section but not the yellow section, which is 10. Okay, so hopefully you're able to read this Venn diagram and you can see where these numbers come from. But again, these lonely 3 students who don't take a foreign language or don't play a sport are kind of left out. So we have a new representation, and this representation is called a contingency table. Sometimes it's called a two-way frequency table. You'll see both. But basically what it is a visual representation of the possible relationships between 2 sets of categorical data. So what's my 2 sets of data? Students who take foreign language, students who play a sport. Now we have to look at all the relationships between that, such as play a sport and taking a foreign language, which we know is represented by this green area, so we put that total there. Playing a sport and not taking foreign language, we know is anything in the blue by itself. That's where the 10 goes. If they don't play a sport but take a foreign language, is represented by this 23 that's only in the yellow circle. And now that those 3 students who don't do either actually have a place within our table in the column that says do not play a sport and do not take a foreign language. So you'll see that every possibility is represented by this table. Now, what we can do here is we can add these values to get totals, and these totals are going to help us find the probabilities throughout the rest of the lesson. So if we take a look at this row is everything related to take a foreign language. So if we add those 2 numbers together, we get the total number of students who take a foreign language, which is 37, which we saw in the first question. If we add up everything in this row, we're going to be adding up all of the students who do not take a foreign language, which is 13. Now, that represents all the possible students. So if you add 37 plus 13, we get a total of 50 students. All right? And something interesting will happen when we look at sports. So now, which boxes represent sports? So I'll use a different color. Every student who plays a sport is represented by this column. So if we add these 2 things together, we get 24 students. Then we have our column for not playing a sport. If we add these 2 together, we get 26. If you add playing a sport and not playing a sport, you get the same 50 total. And that should make sense because you either play a sport or you don't. There's no other options there. Same thing with foreign language. You either take a foreign language or don't. So all the students are represented by those 2 categories. And that's why this is the total number of students altogether. So if we're trying to find the probability that a student plays a sport, well, what are we looking for? Well, the probability that a student plays a sport, remember, it should be the number of students that play a sport over the total number of students altogether. So how many total students play a sport? Well, we have this column right here representing that with the number 24 as the total, all over 50 total students. So if you want to represent that in its most reduced form, we would get 12 over 25, or 0.48, which we know could be represented as 48%. Now in this chapter, we're going to kind of stick with fractions or decimals that terminate, because if a decimal is long and repeating or long and has no pattern, we don't want to make any rounding mistakes. So we're going to stick with most reduced fractions and decimals that terminate. Okay, so 48% of the students play a sport. Now, we want to find the probability that a student plays a sport and takes a foreign language, so does both. So going back to the table, which box in this table represents playing a sport and taking a foreign language? Well, we already know that that's 14. So probability of sport and foreign language is 14 over 50 total students, which is equal to 7 over 25, or 0.28, 28%. Okay, so that's how you kind of calculate probabilities from this table. So what we're going to look at today is something called conditional probability. Okay, conditional probability is basically probability based off of a condition. So what is it? The probability that an event B will occur given that another event A has already occurred. So basically the condition that we have for this particular probability we're trying to find is that another event has already occurred. The notation for this is seen below. We're still using the P to represent probability with the parentheses, but you'll see the two events, right, B and A, separated by this line. Okay, we read this line as given. Okay, so how is this read? The probability that that event B will occur given that A has already occurred. Okay, so what's going to be represented by the first one? Well, that's the event that may or may not occur. That's the one we're trying to find the probability of. And the second one represented is the one that has already occurred, the one that we need to happen in order to calculate this probability. Okay, so we're going to practice saying this line as the word given. Okay, B given A. And we're going to see some examples of this. Okay, so we're going to be looking at problem number 1 on page 696. It's a table that shows students by gender and type of school in 2005. And basically what you're doing is you're going to pick a student at random. So if we pick a student at random, we want to find what the probability is that that student is female given that they attend graduate school. Okay, so again, this is given is represented by that line. This is what we want to figure out. This is what has already occurred. Okay, so how do we figure that out? Well, basically, this represents the total, right? The total that goes in our denominator. Now, why is that? Well, that's the pool that we're picking from. We're picking from students that are in graduate school. So if I add up everything in this row that represents graduate school, 1349 and 1954, we get a total of 3,303 students who attend graduate school. We're trying to find the probability that one of those students is female. So how do we calculate this? Well, we're going to take the number of female students is 1954 over the total number of graduate students, which is 3,003. Okay, now this fraction doesn't reduce, but unless you're a wizard with fractions, that might be something challenging. So I'm going to write it as an approximate decimal, 0.59, which is about 59%. Okay, so there's a 59% chance that the person you pick is female, given that they are in graduate school. So let's pause the video and try the second one. What is the probability that you choose a student in a 4-year program, given that the student is male? When you're done, unpause the video and we can do it together. Okay. So again, this is my total. This is going to be my denominator. So we want to find the total number of males, which is represented by this column here. So if we add 1866 plus 4,324 plus 1349, we get 7,539. That's going to be my denominator. Oops. 7,539. What's my numerator? Well, we want to know 4-year program or 4-year school within the male category. That is represented by this box right here. So that is the number that is going in my numerator. Now again, you could be a fraction wizard, but I'm going to write this as an approximate decimal. So 4324 divided by 7539 is approximately 0.57, which is about 57%. Okay, so now that's if you're given a two-way frequency table or contingency table. But there is another way to calculate this, and that is using the conditional probability formula. Okay, so in the next video, we're going to explore how to use the conditional probability formula to calculate these